Hello again, grade 12s. In this last section of probability, we'll be using the fundamental counting principle to solve probability problems. So you'll recall from grades 10 and 11 that we referred to the sample space as the number of equally likely possible outcomes. Then the probability of getting an event A is equal to the number of favorable outcomes divided by the number of equally possible outcomes. Let us look at our first example, example 1. Consider the letters of the word dreams. If the letters are arranged in any order without repetition to form different words, what is the probability that the word formed will start with D and end with S? So taking into account our sample space would refer to all possible outcomes, and in this instance, this is all 6-letter words that would contain the letters D, R, E, A, M, S. So you'll recall that if we do not allow repetition, in the first block we would have 6, in the second block, since we've used 1, we would have 5, in the third block we would have 4, in the fourth block 3, 2, and 1, and so on. And we would multiply those together. But we know already that there's a shortcut to doing this. This would be 6 factorial. Now, with event A, which is the number of favorable outcomes, they require that the letter or the word starts with D and ends with the letter S. There's only one way of choosing D from the list of letters there, and one way of choosing S. Since repetition is not allowed, we are then left with the letters R, E, A, and M that we can use for the middle part. So since we've used 2 letters already, we would be left with 4 letters for the second block. We would be left with 3 letters for the third block, 2 letters for the fourth block, and 1 letter for the fifth block. Again, we would be required to multiply these together because of the fundamental counting principle. So you will notice that the middle part here, this is just your 4 factorial. Okay, so now combining these two so that we work out the question, okay, the probability of event A is the number of favorable outcomes divided by the number of equally likely possible outcomes, which is your sample space. From the above, we see that the number of favorable outcomes is 4 factorial divided by your sample space, which is 6 factorial. This would simplify to 1 over 30. Let us now look at example 2. A PIN code is formed using 3 letters of the alphabet and using any 3 digits. The numbers and letters can be repeated. Calculate the probability that a code chosen at random contains at least 1 6. So before you start, what you need to figure out is how many letters are there in the alphabet, right? So the letters that you have in the alphabet that we're going to be choosing from is 26, right? Then the digits, your digits are the numbers from 0 to 9. Your sample space will be the total number of possible codes. Now you will remember that the question required 3 letters of the alphabet, right? And 3 digits. In the first 3 spaces, you're choosing from 26 letters, right? So you will have 26 multiplied by 26 multiplied by 26. This is based on your fundamental counting principle, and that is the letters being chosen. Then you consider the 3 digits from 0 to 9. We are choosing from 10. So you are multiplying those 10 together. So the total number of possible outcomes is equal to 17,576,000. We now consider what our event A is. Your event A is the number of codes with at least 1 6. In order to get to the answer where we see the number of codes with at least 1 6, let us consider the complement of this event. The complement of this event is the number of events that do not contain A. So let's consider the number of codes without 6. Since we're only excluding the 6 in this example, we're still choosing 26 letters for the first 3 blocks. We multiply them together according to the fundamental counting principle. We've excluded the 6, so now instead of 10 that you were choosing from, you are choosing from 9. Okay, bearing in mind that repetition is allowed. The number of codes without 6 is equal to 12,812,904. So now to work out the number of codes with at least 1 6, you would take the total of the possible outcomes and subtract the number of codes without 6. Performing that calculation will result in the answer of 4,763,096. Bringing this all together, the probability of event A occurring would be equal to your 4,763,096 divided by your 17,576,000, which is equal to 271 divided by 1,000. You could leave it as a fraction or express it as a decimal, which is 0,271. An alternate method would be the probability of A is equal to 1 minus the probability of not A. This draws on what we've done above, the number of favorable outcomes divided by the number of equally possible outcomes. So in the denominator, you will see that that is your sample space, your total sample space, which we worked out above. And the numerator, this would be the number of favorable outcomes, basically the number of codes without 6. Bringing all this together, you would get to the same answer as you did above. So based on which one you find easier or which one you are more comfortable with using, choose the one that is more suitable to you.